Hey everybody, Mr. Jones here, and we are going to be going over, there it is, solving inequalities today. So, like solving equations, but unequal, things that are not exactly equal to each other. So we're going to talk about all that that means, and we're going to do a couple examples here. So here we go. Um, our inequality symbols, you see that, right, these look like equations that we would solve, but you know they're not equations because they don't have the equal sign, right? You know it's an inequality when it has an inequality sign. And there's four of those. You've probably seen these before, right? You got greater than or equal to, less than or equal to. You know it has, the equal to option there because it has the extra line underneath, right? Um, and then I also remember less than, the less than symbol looks kind of like a capital L on its kind of pushed on its side a little bit. So that's how I remember that one. But yeah, so there's our four options, okay? And we're going to talk about what it means to find a solution to an inequality, um, and how we go about solving these problems, okay? So we got an example here. 8x minus 5 is less than 43, okay? And so when you go about solving this, if you watch some of my previous videos, you would know that I like to think of the equal sign as kind of a barrier between the two sides, right? And the inequality symbol serves the same purpose, okay? There's two sides to this, and that symbol kind of shows, that kind of splits up the two sides, okay? And there's the same rules that apply too to inequalities, okay? What you do to one side, you have to do to the other side, and all that. All those rules still apply. There's one special rule with inequalities that we will go over later on, that's unique to this type of problem, but just about everything else is the same, okay? So if I went about solving this, right, and if I wanted to solve this for x, that means getting x by itself. That means canceling out these other numbers on this left side, okay? And so the first thing I would do to make that happen would be plus 5 to both sides, right? I have to do it to both sides to keep it legal and in balance, okay? So this is saying 8x is less than, the only thing with this line here, sometimes that keeps you from having to write the equal sign, but here it is really important that we keep track of what this sign is, okay? So still write that, like next to it or over the line. 8x is less than 43 plus 5, 48, okay? So that's step one, right? And our goal is to get x by itself, so I'm almost there. I just need to divide this 8 because it is being multiplied by the x, and division cancels that, right? So I divide both sides by 8, and I get an answer of x is less than 48 divided by 8 is 6. So x is less than 6. That's my solution, okay? So why do I have this number line here? Well, just think about what this is saying. X is less than 6, okay? In an equation, we would get answers like x equals 6, or x equals 10, or x equals 0, whatever, right? This isn't saying that. This isn't saying x is not equal to 6, but x has to be, right? X is some unknown number that we didn't know at the beginning of the problem, but now I know it. I know that x has to be less than 6. Okay, so just think about that for a second. X being less than 6. Aren't there multiple numbers that are less than 6? Yeah, right, 5, 4, 3, 2, 1, and you get into all the negatives, right? And so that means with an inequality, we have multiple numbers that can be solutions, okay? And so why I'm showing the number line is there's a way that we could represent that visually, okay? So there's, right, we would sit here forever listing out all the options of what x could be, right? But a number line is a way to show that visually of what are all the answers that x could be, right? It's just anything that's less than 6. So here's how I do that. Here's how I kind of represent that answer visually is, right, 6 is the important number because it can't be anything higher than that. So what I do is I'm going to draw an open circle there, okay? Because if you think about the statement x is less than 6, could x be 6 exactly? Well, no, 6 is not less than 6. So, right, it could be 5.99 or, right, the decimal's just below 6, but it can't be 6 exactly. So I'm going to draw an open circle there, and I'll compare that to one up above there as well. So I draw an open circle there, and then All right, it's kind of hard to see, so I'll kind of draw it bold here. But what this dark line is saying is that, right, all these numbers that are to the left of 6, x could be any of those, right? And so, again, it kind of is a visual way of showing that instead of having us write out all those digits, all those numbers. It's just a visual of saying 6, anything below 6, okay, going to the left here, okay? Now, 2 examples here, as always. If you want to do these yourself, go for it and pause the video, but I'll jump into them right now. So this one, 3 times the group 2x minus 5 is greater than or equal to negative 9. Okay, so I have this one, and the first thing I'm going to do here is distribute. Okay, I'm going to distribute this 3, okay, to just that left side. And again, that inequality sign serves as that barrier between the two sides. Okay, so if I multiply both of these terms in here by 3, I get 3 times 2x, 6x, 3 times negative 5, negative 15. Okay, so that left side becomes 6x minus 15 is greater than or equal to negative 9. Okay, so I distributed that, and now I begin to cancel things to get the x by itself, right? So that's going to mean I plus 15 to both sides. Okay, I do that, and I'm left with 6x is greater than or equal to negative 9 plus 15 is just 6. Okay, and then last step, right? X is almost by itself. I just have to divide that coefficient, that's 6, right? And I do that, and I'm left with x is greater than or equal to 1. X is greater than or equal to 1. Okay, and that would be my solution. Okay? But again, think about that. It's so easy to think, okay, x greater than or equal to 1, right? So 1's the solution, I'm done, right? Because that's what you're used to with equations. But x greater than or equal to 1 doesn't mean 1. It means, right, x could be 1 in this case because of that equal to. But x could also be anything greater than 1. X being greater than or equal to 1, how would I show that on the number line? Well, I'm going to, again, highlight that point 1 because that's my important number. But look, 1 is included in the solution here. And so I represent that visually with a closed circle. Okay, compare that to the first one here. This was an open circle at 6, okay, because 6 was not a possible answer for x, right? It said x is less than 6, so x couldn't be exactly 6. But here, x is greater than or equal to 1, right? That or equal to, right? It could be exactly 1, right? Or anything higher than 1 or greater than 1, okay? So you have 1 there, and then anything greater than 1 would mean it's going more into the positives, right? So 2, 3, 4, 5, and so on. So that would be, there we go. That would be like that, okay? So 1 and anything above that, okay? A little shortcut to help you with where the arrows go, right? Notice how the inequality signs themselves are kind of arrows, okay? So this one was x is less than 6. So the arrow, kind of the direction it was going in, was pointing the same way that this is pointing, right? This is kind of an arrow pointing to the left. And same with this one. Greater than is kind of an arrow pointing to the right. And so on the number line, it's going to go to the right. But be careful. That only works if the variable in your solution is on the left, okay? Because if it said 1 is less than or equal to x, right, I would not go to the left here. This is actually the same way, or this is saying the same thing. But so just make sure if you're following, if you use that arrow shortcut, make sure your variable is on the left, okay? So just a little thing there. Okay, last one. Here's where we run into that rule that's a little bit different from normal equations, okay? So 7 minus x is less than 10. Okay, a simple looking equation, but yeah, let's solve this. So if I wanted to solve this, the first thing I'm going to do is cancel out this 7. And again, the common mistake is to plus 7 because they see this minus. But that minus is kind of going with the x here, okay? So if I ignore that, this is just positive 7, okay? And so adding 7 won't cancel that. 7 plus 7 is 14, not 0, right? It needs to be 0 for it to be canceled. So I need to minus 7 from both sides because that's positive 7. And that'll cancel it, okay? So if I minus 7 from both sides, I'm left with, and I'm going to write this as negative 1x. It doesn't show the 1, but that's kind of the default coefficient. So negative 1x is less than 10 minus 7 is 3. Okay, now here's my rule. Okay, we're going to run into it right here. My last step here is going to be to divide by this negative 1 to both sides. Okay, but when I divide by a negative, okay, the big rule is when I multiply or divide both sides by a negative with an inequality, this sign flips. Okay, you might have heard that before. So my solution here is actually going to be x is greater than, right? It went from less than to greater than. 3 divided by negative 1 is negative 3. Okay. It's not just when the answer is negative, it's that we divided both sides by a negative number. Okay, that's what does it. And if it happens for multiplication too, if I was to multiply both sides by a negative, it would flip the sign around. Okay. So that's the one rule that's different with inequalities, okay? So that's usually that last step at the end that you would worry about that. But yeah, just be on the lookout for that. If you divide or multiply by a negative to both sides, you have to flip that sign from less than to greater than or vice versa. And so again, think about this answer. X is greater than negative 3. So think about that. First thing to answer is, could it be exactly negative 3? And again, the answer to that is, does it have the extra line underneath, right? What I tell my students is, if it has the extra line underneath it, it's going to have that extra filling on your number line, okay? So it does not. It does not have the extra line underneath, so it's going to be an open circle at negative 3, okay? So we draw that open circle there. And then again, our variable's on the left here, so I can follow that arrow rule with, right, it's pointing to the right, and x being greater than negative 3, all the numbers that are greater than negative 3, like negative 2, negative 1, and all the positives, are to the right of that. So it would make sense that we highlight all that we draw our arrow to the right there. So there's the basics. I'm gonna include another video here on multi-step or more complicated inequalities, and then also how we can use Desmos to help us with inequalities as well. But that's the basics. So hopefully that makes sense. Thanks.